Hi, Core Chemistry. Mrs. KJ here, and I am going over Lesson 1.04, Review Gases. Review concepts presented in the lessons, the behavior of gases and gas laws. Much of what we know about the behavior of gases comes from the studies in the late 17th to early 19th centuries. Three prominent scientists, Robert Boyle, Jacques Charles, and Joseph Louis Gay-Lussac, studied the behavior of gases and formulated mathematical relationships or laws that show the relationship between temperature, volume, and pressure of a fixed amount of gas. So, review the goals for the lessons to help you organize the lesson's content, plan your learning. So again, what we talked about so far is explain and apply standard temperature and pressure, or STP, in measuring gas volume, compare and contrast the gas laws, define compressibility as it relates to gases. So the fact that there's empty space in between the molecules allows us to compress the gas. Explain how random motion of molecules and their collisions with a surface relate to surface pressure in gases. So think of the inside of a balloon and the molecules pushing on the edge of the balloon. Relate the random relate the random motion of molecules to the diffusion of gases. So gases, because they're randomly moving, end up spreading out from areas of high concentration to areas of low concentrations. Explain how collision theory explains the behavior of gases. So theory, the fact that they're colliding with each other. Define Boyles-Charles law. So Boyle's law is what? Pressure and volume. And so what stays the same? Temperature and the amount of molecules stays the same. Charles' law, volume and temperature. So what stays the same? Pressure and the amount of molecules. Use Charles' law to solve problems involving gases. Define Gay-Lussac's law. Gay-Lussac is a party. Pressure over temperature. What stays the same? Volume and the amount of molecules. And explain standard temperature and pressure. Remember, gases expand as they get warmer because they have more kinetic or internal energy. They move faster. And so if you are doing an experiment in summer in Minnesota, you're going to get a different result than if you're doing it in winter in Minnesota, unless you have controlled parameters, controlled variables. And so that's why we use STP, standard temperature, standard pressure. So that way scientists all over the world, or even in different seasons, can get the same results. All right, and you have to log in to get the lesson guide if you want it. And so going on to reviewing, again, make sure that you can review them all, and they do give you the solutions for the book. So we'll look at the book next. Key concepts in the behavior of gases. So gases are composed of atoms and or molecules that are in motion. Motion of the molecules is your temperature. The faster they move, the temperature, the higher the temperature. And the motion of molecules is also why we have diffusion, which is what? Molecules moving from high to low concentration. Gas is composed of atoms and or molecules that take up space. Taking up space is simply volume. Gases are composed of atoms and or molecules that have empty space in between them, and they have pressure. This makes them compressible. You can squeeze them together because there's room to squeeze them together because there's empty space, not air. There is not air in between them. There's empty space in between them. Because air is a gas, so it would be more gases. Key concepts in the behavior of gases. Gases consist of empty space and particles, so atoms or molecules. Because gases are mostly empty space, they are compressible, or you can squeeze them together. Particles of a gas are in constant motion. Everything is in constant motion. When they hit the walls of the container, they transfer energy, which is detected as pressure. Just like if you run into the wall, your body transfers energy to the wall, and you applied pressure. Pressure is measured in pascals and kilopascals. Of course, we can also use torr, T-O-R-R, and millimeters of mercury, as well as atmospheres, ATMs. Volume is proportional to the amount of gas at constant temperature and pressure. At constant pressure, volume changes directly with temperature. So that means when the temperature goes up, what happens to the volume? It goes up because the molecules are moving faster and they spread out more. At constant temperatures, pressure is directly proportional to the amount of gas. So when we're talking about pressure, the more gas we try to squeeze into a tire, what happens to the pressure? The higher the pressure. Gas particles diffuse from areas of high concentration to areas of low concentration, and standard temperature and pressure, STP, is defined as 273 K. What does K stand for? Kelvin, or 0 degrees Celsius it would be, but for the gas laws, we always want to use Kelvin, and 100 kilopascals. Key concepts in the gas laws. We have Boyles, Charles, and Gay-Lussac's laws. Boyle's law states at constant temperature, the volume of a fixed amount of gas is inversely proportional or inversely related to the pressure of the gas. So when the pressure on the balloon increases, the size goes down. Increase pressure, lower the volume. And we can use the equation with the constant or the original and the finals. Charles' law states that at constant pressure, the amount of fixed gas is directly proportional to the absolute temperature of the gas. So we can, again, use the equation with the constant K, or the way we're going to do it, original volume and temperature compared to the final volume and temperature. Gay-Lussac's law states that they're having a party. At constant volume, the pressure of a fixed amount of gas is directly proportional to the absolute temperature of the gas. So as the temperature increases, so does the pressure. Or the pressure, rub your hands together. Okay, if you rub your hands together, you're increasing the pressure, you're increasing the temperature. And of course, temperatures must be in Kelvin. So if you have Celsius, what do you need to do to change it to Kelvin? Add 273. All right. So we have our mastery map of gases. So go ahead and hit pause and fill them in yourself. Just kind of think of where they need to go. And so gases are governed by, we should have Boyle's law here. Gases are composed of atoms and or molecules that are in motion. That's temperature. Atoms and or molecules take up space. That means volume. Atoms and or molecules have space in between them, making them compressible, and that is pressure. Then it tells you to go to the problem book. And guess what? You should go to the problem book. So let's take a look at that. So how do you get to the problem book? The problem book is under content. And I know your screen looks a little bit different, but hopefully it's close enough that you can follow it along. And course materials. And look at that. We have a solution key and we have a problem book. And there's different ways you could see that there's different links. And then of course the solution key is right there as well. And you can download it on a mobile device. So no excuses. Woohoo, exciting. All right, so we need to go to problem set 52. And problem set 52 starts on page 114, which is kind of like right below where my mouse is right now. I know you can't see it, but the behavior of gases. Objective, explain bulk properties of gases in terms of the spacing, motion, and collisions taking place at the molecular level. So behavior of gases. The kinetic theory of gases describes the movement of gases. It explains properties such as compressibility, diffusion, pressure, and temperature in terms of the motion and collisions of the particles that make up the gases. So the reason we have all these things is because the molecules are moving and hitting each other. It's very violent. The kinetic theory of gases treats gases as very special particles. And again, particles means atoms and molecules, that are widely spaced, move rapidly and randomly, and collide with one another and with the walls of their container. The kinetic theory explains the compressibility, pressure, and diffusion of gases. Gases are compressible, so their volume decreases as their pressure increases, because the distance between the particles. As pressure increases, the particles get closer together. You're squeezing them. Because there is so much space between the gas molecules, the volume of a gas can decrease significantly as pressure increases. The collision of particles with the walls of the container cause the gas to exert a pressure on the walls of the container. So it's going both ways. There's pressure if you're squeezing the balloon, but there's also pressure inside the balloon of the gas molecules pushing against the wall of the balloon. The rapid motion of the gas particles and the collisions between the particles cause gases to diffuse or spread and fill the entire volume of a container. Example 1, explain gas pressure. All right. A scientist places 1 mole of a gas into each of 2 containers. The first container's volume is twice that of the second container. All right, so the second container is twice as big. Explain why the pressure the gas exerts on the wall of the second container is greater than the pressure it exerts on the wall of the first container. So the first container is twice as big as the second one. So the first one's twice as big, and we're saying that the smaller container is going to have more pressure. Why? Hit pause and think of your answer. Recall relevant information. Gas particles have mass and are in constant motion. Gas particles frequently collide with the walls of the container. Colliding objects, right, run into each other, exert force on each other. Pressure is a measure of force per unit area. The more gas particles that strike a given area, the more force is exerted on the area. So the greater the force per area is, the higher the pressure. Solve. In a small container, a given gas particle does not have to travel very far before it hits the wall. Therefore, the gas particle in the smaller containers collide with the walls more often than those in the larger container do. The larger number of collisions results in a greater force being exerted on the container walls. The greater force explains the higher pressure in the smaller container. Remember the behavior of gases. Many of the properties of gases result from the motion and distribution of the particles in the gases. When a gas absorbs heat, its particles move faster because they're getting more energy. If the volume of the gas container is fixed or stays the same, the temperature and pressure of the gas will increase. If the pressure on the gas is fixed, stays the same, its volume will increase and its temperature will remain the same. Explain diffusion of gases. The diagram shows 2 containers filled with 2 different gases, represented by red and blue dots. The containers are connected by a tube with a closed valve. Describe how the particles will be arranged after the valve is left open for 1 day. So tip, you can think of gas particles in a container like strangers moving around in a room. In a large room, people will tend to spread out fairly evenly, right? If there's 100 people who don't know each other, they don't sit in a corner. They spread out all over. Similarly, gas particles in a container tend to move out and fill the whole volume of the container rather than remaining concentrated in one part, like one corner of the container. So hit pause, get your answer. Recall relevant information. Gas particles are in constant random motion. Gas particles collide often with each other and with the walls of their container. Because the motion of the particles are random, the angles at which they collide will also be random, and the particles will travel in all possible directions. Because collisions are frequent, each particle will change direction many times through the course of the day. So this blue might have started here, might hang around here for a while, then go over here, and then maybe it'll hang out in this corner, and maybe it will end up right back over by where it started. That's possible. Many particles will collide at an angle that will send them straight through the tube to the other side, and that will happen, right? They're going to end up going through. Once on the other side, collisions will cause the particles of the 2 gases to mix randomly. As a result, both containers will have a random mixture of roughly equal the same amount of particles. So it's not going to be perfect, right? It's not going to be like red, blue, red, blue, red, blue. But overall, it is. You're going to have red and blue everywhere. All right, problem set. Okay, and it wants you to do the first 3 problems. So number 1, a teacher uses a permanent marker to write on a chart in the front of the classroom. In a few minutes, everyone in the room can smell the odor of the marker. Use the kinetic theory of gases to explain this observation. Hint, most odors are carried by gas particles. So get your answer for that. We'll go to the next one. So hit pause, and I'm going to read through them all, and then we'll look at the answers. 2, explain why increasing the volume of a container decreases the pressure of a gas in the container, assuming the temperature remains fixed. And 3, most of the gas particles in the air are either nitrogen molecules or oxygen molecules. If you could see the nitrogen and oxygen molecules in a sample of air, how would they probably be distributed? Explain your answer. So again, hit pause, get all your answers. And my timer is going to run out. We will have another part to this lesson, but you can hit pause and you can read through these on your own. And big idea, you should have mentioned diffusion. You should have mentioned collisions are random. You should have mentioned they spread out from high to low. Number 2, the larger the container, the more spread out, the less likely to hit the walls. Therefore, the less collisions, the less pressure. And the last one, constant motion, they should be spread out pretty evenly everywhere.